When I say square root of 36 is equal to 6 and square root of 4 is equal to 2, there are numbers that do not have exact square roots, and those are the numbers we'll be dealing with today. Hi, my name is Faithful and welcome to Alpha Space, where we simplify maths, physics and chemistry for students like you. In today's video, we'll be simplifying surds, and trust me, surds are easier than you think. Before giving the definition of surds, there are terms I would like us to be familiar with. First one being your rational number. Your rational number. And what are rational numbers? Rational numbers are numbers that can be expressed as a quotient A all over B such that B is not equal to 0. I'll say it again. Rational numbers are numbers that can be expressed as a quotient of two integers, A all over B, such that B is not equals to 0. What are the examples of rational numbers? The examples of rational numbers are 1 all over 2. Let me write it. Example 1 over 2, 3 all over 4, and 5 all over 3. So what it therefore means is, in simple terms, or basically, rational numbers are fractions. Simple terms, rational numbers are fractions. The second term I would like us to be familiar with is your irrational numbers. Irrational numbers. And what are irrational numbers? Irrational numbers are numbers that cannot be expressed as a quotient A all over B of two integers. What it therefore means is, in simple terms, irrational numbers are numbers that cannot be expressed as a fraction. So, example we have is your square root of 2, cube root of 2, your pi, etc. So those are your examples of irrational numbers. And based off of these terms we have just defined, we can now give a definition of surd. Surds are irrational numbers in the form of roots. So that means irrational numbers that are in the form of roots are referred to as your surds. Irrational numbers in the form of roots are referred to as surds. So for example, when I have square root of 2, cube root of 2, fifth root of 27, these are all examples of surds. But in this video, we'll be looking majorly on quadratic surds. That is, surds in the form of square root, not cube root, not fifth root, not fourth root. We only look at quadratic surds. So we'll be looking at the rules for surds. Now, the first rule I would like us to be familiar with. The first rule states that if I have an expression A square root of B plus C square root of B, it is equal to A plus C square root of B. This is what the first rule says. The second rule states that if I have this expression A square root of B plus minus C square root of B, it is equal to A minus C square root of B. This is referred to as your addition rule, and this is your subtraction rule. So let us look at examples concerning this rule. It therefore means that if I have an expression A plus C square root of B, I will just add these two terms on the outside and I'll carry one of it here. But if I have for a subtraction, I'll minus these terms and I'll bring one of it. Now, there is an exception to this rule, but I would like us to solve an example concerning these two rules before I tell us what the exception is. We are asked to simplify an equation like this based on the addition rule we just learned, we know that based on the rule, this is my A and this is my what? This is my C. So I will just say 4 plus 2, and I'll pick out one of the square roots, put it like this. And therefore, my final answer will be what? 6 square root of 2. And this will be my final answer. You can use the same process, can try it, change the plus sign to what? Minus. And you will see that the same rule what applies. You just have to minus these two terms and carry one of it and bring it down. But recall I stated that there's an exception to this. If you have an expression where these terms in the square root are different, the addition and the subtraction rule will not work in that instance. For example, if I have 4 square root of 2 minus or plus 2 square root of 3, this question cannot apply to the addition rule. So in such kind of questions, the addition rule will not work. So it therefore means the addition rule will not work, will not apply to such kind of to such kind of problem. So for an addition rule or for a subtraction rule, the terms within this square root must be the same for it to apply. They must be the same. Now the third rule states that if I have this expression square root of AB, this is the same thing as square root of A times square root of B. This is what the first expression says. The third law says, Or you can reverse it and say, if I have an expression A times B, it is the same thing as square root of AB. Anyhow you decide to put it, it is still the same rule. So if I have this expression, I can write it as this. If I have this expression, it can be written as this. And this is what we refer to as your multiplication rule. This is your multiplication rule. The fourth one, is if I have this expression A square root of B multiply if I put it in brackets, multiply C square root of D. It is the same thing as me saying A multiply C square root of BD. So if I have an expression like this, A multiplying C here, B multiplying D. Recall that this is the same thing as this, so it's the same thing as multiplying B times D. It will give me BD. So these are the third and the fourth rule. Now let's briefly look at examples concerning this rule so that we'll be able to know that yes, we understand this rule very well. We are asked to simplify this kind of equation based on the third rule and the fourth rule we just looked at. Based on this, if we want to simplify the first one, it will be square root of 2 times square root of 3. And based on the multiplication rule, it will be 2 times 3. So therefore, my final answer is square root of 6. If I'm to simplify the second one, based on the fourth rule that we looked at, 2 square root of 3 multiplying 3 square root of 5, it will be equal to 2 times 3, which is 2 multiplying 3. I'll put it like this, 2 multiplying 3, in bracket, 3 times 5. So my final answer will be 2 times 3, which is 6, and 3 times 5, which is 15. And this will be my final answer. So let's look at the fifth and the sixth rule. Now, before looking at the fifth and the sixth rule, there is something I would like us to know. And that will be, whenever you have multiplication, or whenever you have sorts involving multiplication, the terms within the square root must not be necessarily the same. That's what I mean to say. They must not be necessarily the same. For example, when we discussed about square root 2, let's say 2 square root of 3 multiplying 3 square root of 5. If you notice in this, the terms within here are not the same, but we still perform them. So what it therefore means is for sorts involving multiplication, the terms within this square root may not be necessarily the same. Now, in a situation where they are the same, for example, if I have 2 square root of 3 multiplying 3 square root of what? 3. What I'll have is 2 times 3, which is what? 6. It will now be what? In brackets, square root of 3 times 3, which is what? 3 times 3, which is 9, obviously, and we have 6. Square root of 9 is what? 3. And 6 times 3 is what? 18. So sorry. Square root of 9 is what? 3. And 6 times 3 is what? 18. So, what it therefore means is whenever I have sorts involving terms in the same bracket, in the same square root, 2 square root of 3 in sorts multiplying square root of 3 in sorts, whenever you have them in the same term in the square root, the final answer will just be the term in the square root. That's just it. So whenever I have terms involving sorts and the terms within the square root and are multiplying, whenever I have them multiplying, the final term will just be what? The term in the square root. So rule states that if I have this square root of a all over b to be equal to what? Square root of a over square root of b, and this is what? Your division rule. This is your division rule. Now let's look at the 6th rule before we look at examples concerning this rule. If I have a square root of b divided by c square root of b, this rule states that what? A all over c square root of what? B all over d. And this is what this rule basically states. So let's look at examples what? Concerning this rule. Now let's briefly look at examples concerning the rule we just learned. Now concerning the division rule, let's solve question number 1. We have that if we have an expression like this, based on the rule, we can split them to have square root of 144 all over square root of what? 16. And therefore, my final answer will be square root of 144 is what? 12. And square root of 16 is what? 4. 12 divided by 4 is equal to what? 3. And this will be your final answer. Now, concerning the second rule, if I have 12 divided by 3, sorry, the board is shaking. If I have this, if I want to split it like this, it will be very unreasonable because we cannot have square root of 12 and we cannot have square root of 3. So what it therefore means is it is not at every given point that you have to split them in order to find the square root. You can actually divide them here if they are divisible. So 12 divided by 3 is what? 4. And square root of 4 will be what? 2. And this will be my final answer. So let's look at number 3. So to solve number 3, we'll use the 6th rule we just learned. So 6 divided by 12 divided by 2 square root of 3. 6 square root of 12, sorry, divided by 2 square root of 3 will be equal to, this is our A and this is our C, so it will be 6 divided by 2 square root of what? 12 divided by what? 3. And as we just learned, 6 divided by 2 is what? 3. As we just learned that 12 divided by 3 will give us what? Square root of 4. And square root of 4 is equal to what? 2. So therefore, our answer here will be 2, and 3 times 2 will be what? 6. As simple as this. As you can see, it's very simple. So let's move on to the 7th and the 8th rule. For the 7th rule basically states that if I have square root of a to the power of 2, it's the same thing as what? Square root of a, put it here in brackets, like this, which is equal to what? A. Because this square will cancel out this square root and you have a. Basically, square cancelling out this square root. You can even do it from here. Square cancelling out square root and get a. Now, the eighth rule is saying the same thing, but in another different fashion. If you have square root of a all to the power of n, it is the same thing as me saying square root of a to the power of n. So let's try to solve these examples. For this, using the rule we just learned, square root of 6 like this will be equal to square root of 6 all squared, which will give us 6 squared is what? 36. And square root of 36 is what? 6. That is why I said about the rule, there is no need going through this lengthy process. As mathematicians, we try as much as possible to reduce complex problems to making them what? Simple. In alpha space, we'll try as much as possible to reduce complex process and make it what? Very simple. So what it therefore means is, from here, looking at this question, you just cancel this in your head, and you already know that your final answer will be what? 6. But for things that do not have square roots here, and this is a square root, and this is what? Raised to the power of what? 3. So if it were to be a cube root, we can cancel it. But since it is not a cube root, and I've said from the beginning of this video that we're working with only quadratic surds. So what it therefore means is, if I have this square root of 2 or 3 is the same thing as what? Square root of 2 to the power of 3. And square root of 2 to the power of 3 is what? 8. And this will be what? Square root of 8. You don't stop here. Why? Because despite the fact that this is 8 and you can stop here, it is not advisable because 8 can actually be reduced further. And since 8 can be reduced further, we can write 8 to be what? 4 times 2. And based on your multiplication rule, that's how this will begin to add up together now. You see how they started adding up? So 4 times 2, we can now split it based on the multiplication rule to be what? Square root of 4 multiplying square root of 2. And square root of 4 is what? 2. So 2 times square root of 2 will be what? 2 square root of 2. And this will be your final answer. You can see, just as you've learned the multiplication rule, you have just applied it to another question. And that's how you keep getting better at what? Sorts. So let's look at the 9th and the 10th rule. The 9th and the 10th rule. You can see the 7th and the 8th rule are very simple. So let's look at the 9th and the 10th rule. They are actually very, very simple. The 9th rule states that, let me write it here, the 9th rule says that if I have this surd A always to the power of negative m, it is the same thing as what? 1 all over A, the power of m, and you put your what? Square root. Now, how did we come to this? Look at, let me write something here. Recall from your sorts, from your indices, I mean, if I have, and by the way, if you don't know much about indices, you can check my channel. You see my videos on indices. You can watch it and you understand how what I'm going to do here came about. From indices, if we have a raised to the power of n, it is the same thing as what? 1 all over a to the power of n. So in the same fashion, this raised to the power of minus m is the same thing as 1 all over a raised to the power of what? M. And that's how we got to the 9th rule. Now to the 10th rule is 1 all over square root of a all raised to the power of negative m. Again, from your indices, recall if I have something like this, I had this. Now what it therefore means is I can write this equation to be 1 divided by square root of a raised to the power of what? Negative m. And I can do this to be 1 divided by 1 all over square root of a to the power of m. Now, to make this division a multiplication, I'll carry this denominator here that is close to the sign. I'll carry it to the top, and I'll bring the 1 to the bottom. I'll carry it to the numerator, and I'll carry the 1 to the denominator. So I will therefore have 1 times square root of a raised to the power of m all over 1, and my final answer will be square root of a raised to the power of m. So therefore, I can now write this to the square root of a to the power of what? M. And recall from the rule we just learned, we can write this to be what? Equal to what? A to the power of M square root. And these are the rules for sorts. With all these rules, you can solve any type of sort. You can solve any type of sort question expression you are given to all these rules. So understand this rule, practice this rule. Let's look at examples concerning the 9th and the 10th rule. Then there is an exception I want us to be aware about. So stick around. Let's look at the examples for the 9th and the 10th rule. And I'll give you what the exception to what one of the rules for sorts that I did not talk about. I left it for the last. They say you should reserve the best for the last. So I will give us what the examples now. We'll be looking at this. As we've learned, the 9th and the 10th rule. I'll be solving this, but I'll leave this for you guys to solve because I know you guys are brilliant and intelligent again. So I would like for you guys to solve this and drop the answer for me in the comment section. I will do well to reply your questions, and also I will do well to acknowledge you guys when you comment on the comment sections. Okay, so for this, which I'll be solving, and I'll be leaving this for you guys because you guys understand this now, will be that if I have this, based on the rule we just learned, is equal to what? 1 all over square root of 2 raised to the power of 2. And 2 squared is what? 4. 1 all over square root of 4. Square root of 4 is what? 2. So my final answer will be 1 all over 2. And this will be my final answer. So I'll be waiting for you guys. Solve this and drop the answer for me in the comment section. Like I said, there is an exception to one of the rules I did not state. The exception is this. If I have square root of m plus n, do not do this mistake by what? Saying square root of m plus square root of n. What it therefore means is whenever you have an equation, an expression like this, do not do it like this. They are not the same thing. So square root of m plus n is not equal to square root of m plus square root of n. And in the same fashion, if I have square root of m minus n, it is not equal to what? Square root of what? M minus square root of n. And that will bring us to the end of this video today. As you can see, sorts are very easy. Just know that it requires practice, requires practice, requires practice. So try as much as possible to practice these rules all over again and what? Solve questions concerning them. In the next video, we'll be looking at what? Reduction of sorts to their basic form. See you guys in the next video.